Welcome back to 1190 KNOW, when you need to know. Today's program is part of our series, Believin' in Regions, an exploration of our world. Today we are focused on the Pacific Northwest region of the United States. This region stretches from the ocean in the west all the way until, well, wherever you want to draw the line in the east. Remember, a region is an idea, not a fact. It's all about what you want to use this idea to do. And today, we're using the idea of the Pacific Northwest to talk about rain, rivers, sediment, salmon, power generation, politics, and dams and demolitions. So I guess you could say the key feature of our conceptualization for regionalization is precipitation. Where does it rain, and where does all this rain go, and how does it affect our lives? That's what this program is all about today, folks. And remember, you can call in with your questions at any time, so feel free to call 1-800-KNOW-NOW. That's 1-800-KNOW-NOW, and you will get to know the answer to your question right now. Okay, moving on. So, what's the deal with all this rain? Well, really, it's all related to the region. We know that the prevailing wind in these parts is from the west to the east. And what's out there in the west? A whole lot of water. That's right, the ocean. So through evaporation, this water comes inland, and then what happens? Well, a key feature of this northwest region is mountains. We got all kinds of mountains. Olympic Mountains, Coastal Mountains, Cascade Mountains, the Blue Mountains, and way up where Montana, Idaho, and Canada meet, we've got a part of the Rocky Mountains. By the way, folks, way up there is where the Columbia River is born. So what do mountains have to do with rain? Well, there is a little phenomenon called orographic uplift. Some people call it geographic uplift, but it's the same thing. Masses of air, which are holding all this evaporated water vapor, are pushed eastward by the prevailing wind, and then the earth pushes the air up higher and higher. And as it's getting higher and higher, it's getting colder and colder. And the fact of the matter is, cold air can't hold moisture very well, so it starts to rain. Alright, so we've got all the moisture moving in, we've got the mountains, and so we've got a lot of rain in this region. And so what happens to rain after it falls? It collects in streams and rivers and flows out to the sea. Much of this region drains to the ocean by way of the mighty Columbia, which, before being dammed, it was capable of moving over 1 million cubic feet of fresh water per second out to the ocean. Boy, that's a lot of water. So it's no surprise that all this rushing water has given rise to quite a few dams. There are over 70 major dams in Oregon and Washington alone. We use these dams and the reservoirs they make for flood control, irrigation, and power generation. But one interesting thing that all these river stoppages have done is to stop the flow of sediment to the ocean. That's right. Used to be that sand and little rocks would wash out to the ocean in large amounts. Now, in the still water of the reservoirs behind the dams, all this sediment falls to the bottom and sticks there as deposits. So what's the big deal with that? Well, you know all those nice sandy beaches that Oregon and southwest Washington have at the ocean? Well, they are dependent on fresh supplies of sand from the Columbia, or else the ocean would eventually erode and wash those beaches away. Yep, that doesn't sound like good news for people who like the beach. Oh, and we have our first caller on the line now. Hello, caller. You're on the air. Go ahead with your question.
Yeah, hi. I was just wondering, what is up with the removal of the Condit Dam in Washington?
Excellent question, caller. Well, I'll tell you what's going on, and it's going to be a doozy. That dam, which is located on the tributary of the Columbia River called the White Salmon River, is almost 100 years old, and it is a major barrier to salmon runs on that river. So they are taking it out as soon as the summer of 2011. The trick there is that the dam is 125 feet tall, and there is a lot of buildup and sediment behind it. Engineers and environmentalists have decided that punching a hole 18 feet wide at the bottom of the dam is the best approach. This will release 2 million cubic yards of sediment into the lower parts of the White Salmon River and into the Columbia. The scientists think that the river will be able to handle all this material because, hey, it's natural stuff, right? It's not like it's toxic or anything. Also, we learned from the removal of the Marmot Dam on Oregon's Sandy River in 2007 that rivers can digest a large amount of sediment fairly quickly, incorporating the material into healthy river structures. In that dam removal situation, Over 730,000 cubic yards of sediment were washed away in under 24 hours. Scientists were amazed. Today, the Sandy is as healthy as ever. Well, that's all the time we have today, folks. Join us next time as we discuss the wonders of Russia's polar region in our ongoing series, Believin' in Regions.